Okay, so today we're going to start with eigenvalues and eigenvectors. Now, the eigenvalues and eigenvectors of a matrix really convey a lot of information. Okay, so what is an eigenvalue and an eigenvector of a matrix? Okay, so if you can have a matrix A act upon a vector V, okay, and all it does is multiply it by lambda, which is a constant, times that same vector, right? Well, lambda is the eigenvalue and V, let's do it like this, is the eigenvector. Okay, so if you have a matrix act upon a vector and all it does to that vector is it multiplies it by a constant, well, that constant is going to be the eigenvalue, and the vector that it is acting upon, that the matrix is acting upon, is the eigenvector. Okay, so let's see how we're going to try to solve for one of these things. Okay, so we have A times V is going to equal lambda times V. Okay, so why don't we just track lambda V over to the other side of the problem? All right, let's say that this was a 2x2 matrix. Okay. Okay. Well, another way that I could write this would be that A, right, now multiplied by, I'm going to phrase it like this: lambda 0, 0, lambda. So I can on B. Actually, let's start that over again. So I'm taking this problem right here. So this would mean that matrix A acting upon vector V now minus, like I said, let's assume this is 2x2, 0, lambda. Now acting upon V, okay, this would equal 0 and 0. Okay. Well, I've got a common V in there that I can pull out of this thing. And so I could rewrite this problem like this. Right, matrix A minus lambda multiplied by the identity matrix, and then multiplied by V is going to equal 0, 0. Okay? Okay, so how are we going to deal with this situation? Okay, so what are we going to do is first we're going to find the eigenvalues. Okay, so to do that, what we're going to do is we're going to take the determinant of A minus lambda I, and we're going to set that equal to 0. Okay? That's going to give me the eigenvalues. By taking the determinant of A minus lambda I and setting it equal to 0, I'm going to get the eigenvalues. Okay? And then step 2, that would be the eigenvectors. So once I have my lambdas, what I can do at that point is I can actually try solving this problem up here. So to find the eigenvectors, I'm going to solve A now minus lambda I okay, depending on the size, there might be more zeros there. So the very first step of any of these problems is to solve for the eigenvalues by taking the determinant of A minus lambda I and setting it equal to 0. Great. Once I've solved for those eigenvalues, for each eigenvalue that I find in the problem, I'm going to set up this situation right here, and I'm going to try to solve, so for lambda 1, I'm going to find V1. Okay? For lambda 2, I'm going to find V2. So you're going to have multiple eigenvalues, and with each individual eigenvalue, you're going to be having an associated eigenvector that goes along with it. In this situation that we're looking at right here, we've actually seen this problem before. What is this problem? This is looking for a null space. Okay? So when you take the determinant of A minus lambda I and you set it equal to 0, what are you doing? You're making these linearly dependent vectors. And since they're linearly dependent vectors, you're going to have free variables, okay? And that allows you to actually solve for a null space, okay? So what are we looking for when we're looking for solving this problem right here? We're looking for the null space of A minus lambda I, all right?